page 2 of our cross-section notes. We're going to try to do an example. We're going to try to go step by step through the process of how to actually find this volume. So again, we're going to be given a curve. So in this case, you have y equals 2 sine x. And what this is going to be our base. Okay, so you guys can kind of see the base is being drawn here on the x, y plane. We know that sine, it's going to be x equals 0. It's going to start there. And then over here, it's going to be x equals pi. Okay, so that's the first half of one period of sine x. And what's going to happen is we are going to grow, okay, our slices. In this particular case, our slices are going to grow perpendicular to the x-axis. Okay, so cross sections perpendicular to the x-axis, and our cross sections actually will be semicircles. Okay, so those are what our slices will look like. They'll look like semicircles. You can kind of see it here. Okay, now you don't actually have to draw three-dimensional pictures, so that's a good thing, but you just want to kind of visualize or at least understand kind of what's going on. This distance right here is S. This is our reference distance. And so depending on where S is being calculated, you guys can kind of see different S's, right, will make bigger semicircles or smaller semicircles. So this is a different S down here. We go on from there. Okay, so let's just kind of go through the steps on how to do this. Okay, but overall, let's kind of before we start this, can we just over here just write down what S is equal to? So to remember is this distance, and the way we find that distance is in our previous topic. Our previous topic is we found the area between two functions, and if you guys remember, it's top function minus bottom function. Okay, so top function minus bottom function. The top function in this case is 2 sine x. Okay, and our bottom function is going to be 0. Okay, so remember, this is like y equals 2 sine x. That's one equation. And then this one is y equals 0, which is the x-axis. Okay, so this is what S is equal to, 2 sine x. Okay, all right. So let's move this up. Okay, so find the area of the semicircle of one slice. Okay, well, if we want to find this area, so let's say, let's do this in red. So what we want to do is we want to find this area right here. Okay, so this area is area equal to 1/2 pi r squared. Everyone good with that? Okay. This distance right here is S. Okay, and we know S is 2 sine x minus 0. So what we're going to do is we want the radius. If this whole distance is 2 sine x, then the radius is half of that. Okay, so this would be 1/2 pi, and then what we're going to put here is 1/2 of 2 sine x. Close my parentheses, squared. Okay, does that kind of make sense? Okay, so this is half a circle. Pi r squared is the area of a full circle, half of that. And then we replace the radius, and the radius is half of the diameter. If the diameter is 2 sine x, then we put half of 2 sine x squared. Okay, we get this to be 1/2 pi. Now 1/2 and 2 cancel out, so we'll have sine x squared. Okay, so this right here is the area of this little cross section. Okay, now if we want to do thickness, okay, in order to give this thing volume, we need to figure out what the width of one of those slices is. And so we're going to create a little bit of thickness right here. We're going to call it dx. Something like that. So dx. So that's going to be how thick our area is going to be. And what this will be, this will give us a certain type of volume. So what that means is, think of it like half a quarter. If we cut a quarter in half, not only does it have the circle, the half a circle on the top, but it also has a little bit of thickness, okay? And that thickness is going to be represented by dx. So what's the width of one slice? That's what dx is. All right? Okay, so let's kind of keep doing this. We'll keep going down a little bit more. Okay, what's the volume of one slice? Well, if we know that this right here, is our area, we give it a little bit of thickness. Think of it like base times height. If you have your base area and you have the height, you can find volume. And so multiplying those two things together, the width and the area, will give us the volume. Okay, so let me see if I can do this here. Okay, so what's the volume of one slice? Well, it's going to be the area times dx. Okay, and that's the volume of one slice. So this little blue thing, if we just kind of keep it going down there, area times dx. All right. So that's the goal for a lot of these problems. You figure out the area, you multiply by a little bit of thickness, and you get volume for one slice. And then after that, okay, after that, how do you add up all the slices together? Well, we use a integral, right? So the integral will be like this. So we draw a little integral. Now, remember it goes from x equals 0 to x equals pi. So x equals pi, 0 to x equals pi. And this part right here will always be, remember, area. And so our area was, for one of our cross sections, is 1/2 pi sine x squared, and then times thickness, okay, which is our dx. So this area has units squared, thickness has 1 unit, so like centimeters squared times centimeters, you'll get centimeters cubed, which is volume. So that's how this works. Okay, hopefully that made sense. Again, email me questions if you do have any of them, and then I'll try to answer them. Okay.